Welcome to episode 29 of The Mobile Classroom, the weekly video podcast where we demonstrate today's most popular technologies. And this episode is about networking at home. The idea is when we are working on our home networks, and we all tend to have these home networks these days, so we have our internet connectivity that's always on, whether you've got a cable modem, a DSL, satellite link, or anything else. And occasionally we'll have challenges there. There'll be a problem communicating through that connection. And of course, our question is the problem in my house? Is the problem with my provider? Is there something else going on over the internet? How can I start troubleshooting some of those things right now before I get on the phone with my ISP? Because like all ISPs, the first thing they're going to tell you to do is turn your computer off and back on again. But if you've already gone through those steps, you may be a little bit more ahead, and you may be able to determine if the problem is really something that you can fix inside of your own house, or if it's something that the ISP should really address. In today's episode, we'll start with talking about this home network. What are all of these pieces that we have? We have boxes and devices that have been brought in by our ISP. We may have purchased a modem, a router. We may have purchased a wireless access point. What are all of these devices, and how do they all fit together? And how can we use those to help troubleshoot what we're doing inside of our network? In fact, how do we even know if our wireless connectivity is the best possible connection it can be? I hear problems all the time from friends that say, I'm on my wireless connection and then it goes away and then it comes back. But they've never really looked to see how their wireless health really is. And we'll look to see how we might be able to look at some of those things too. I'll also take you through some very simple do-it-yourself troubleshooting with your connection from your home office, out to your ISP and out to the internet that might help you determine a little bit better of where your problems are really occurring. We'll go through a lot of different troubleshooting techniques in that one. And lastly, I'll show you some advanced troubleshooting techniques, some things that the professionals use to help troubleshoot networks. This week's podcast is absolutely free. You'll be able to see it from the very beginning to the very end, unedited, with nothing taken out of there. Every third video we do is one that is exclusive to mobile members. Not everybody gets to see those from beginning to end. You get about a 5-minute summary view of that one. And we still have those 30 to 45-minute podcasts in those every third videos that just our mobile members will have access to. Mobile members also have additional capabilities every week in what they're able to view, the resolution they're able to view. All of our mobile members see every single one of our podcasts at 720p HD resolution. That's 1280 by 720, which is the native resolution that I'm looking at on my screen. So if you're looking at this on your iPad, on your desktop, on your other devices, you'll be able to see it crystal clear exactly the way that I see it. If you'd like to see more information about that, you can join our website and help support the podcast at themobileclassroom.com/members. Before we get into troubleshooting a home network, I thought it would be nice to give you a picture of what a very typical home network might look like. This is something that you very commonly see. You have an internet connection out here. In our industry of networking, we tend to create this cloud to describe the internet because inside the internet is a lot of different kinds of components that get our packets from point A to point B. And just to summarize everything, we always draw a cloud, a little picture of where the packets are going in, and they might come out on the other side of the cloud. And really, we don't care what's in the middle. Your internet service provider, whether you have a DSL line coming in, you might have a cable modem coming in, they're bringing in their equipment and they're putting it on the end of that connection. So your cable connection that you normally plug into a television would go right into this cable modem. The connection coming from your phone line would plug into a DSL modem. These are usually referred to as modems. They are modulators, demodulators that take that signal coming across the link and are able to put it into a different form. In reality, it may not be audio signals that it's doing. It may be a different kind of digital signal that's being remodulated into something like Ethernet that comes out the other side of this. And that's the connection we're given by our ISP. They usually will hand us an Ethernet cable and say, here's your connection to the internet. Many people plug directly into that Ethernet cable, which is a really bad idea. That is an unfiltered connection to the internet. There's a lot of bad things that are on the internet. You need some type of protection between you and what's happening on the internet. I always recommend that you get a router for your house, a home router. You can pick these up relatively inexpensively, anywhere from $25 to $100, depending on speeds and capabilities. You can pick them up almost anywhere these days, and they protect you first from anybody coming into your home network from the internet side. They are a great filter. They are a firewall, essentially. That's a firewall capabilities that it's built into there that prevent any of the bad guys from coming in. It only allows in the things that you would like to come in. If you go out to Google, it's only going to allow that Google search to come back into your network. Really, really useful to have that home router in your connection. And so when we start trying to figure out where's our problem happening, look at all the different points where there could be an issue. There could be an issue on your workstation. There could be an issue with your home router that you purchased, that you own, that's your responsibility. You may have a problem with the connection from the provider, from your internet service provider. This modem might be bad, or the connection coming into the modem might be bad. They might be having some local problems on their side, or ultimately the problem may be with the website you're hitting on the other side of the internet somewhere. These are every step along the way. We need to troubleshoot this. We need to know how far can we get. And we need to know if the problem is back here, there's really no reason to call our internet service provider. However, if the problem's somewhere out here, that's exactly when we should be calling them. So it's good that if we were able to provide and figure out what was going on prior to calling them, we'll be just a little bit further ahead of the game when it comes to troubleshooting the problem. My network and many people's networks is even a little more complicated because the home router that we purchased actually allows us to also provide wireless connectivity for the rest of the house. This is really where most people are going. You don't have to run any cables. You don't have to have connections going through your walls, wires running through your walls. You don't have to have electricians or experts in cabling to come into your house and cable up every room. Those days are long over. These days, everything seems to be going in more of a wireless direction. So of course, in my home, I have a wireless connection on my router. So really, I've got a firewall, a router, and a wireless access point all combined into this one unit. Costs about $50. You plug it into the network, and now anything that's in your house that's wirelessly connected can use that connection. And I have a wireless printer on my network. All of my devices are wireless. I have wireless on my mobile phone. I have an iPad that's wireless. I have a lot of different devices. I don't have to worry about where I am in the house. I don't have to worry about plugging into any cables. I simply connect wirelessly. But again, this is another troubleshooting spot. I know that if somebody decides to use the microwave oven, my wireless connection is not going to work very well because the signals put out by that microwave oven, it puts out interference that is exactly on the frequencies that's used by my wireless connection. So you have to have some way to be able to tell, how is the wireless health? How's my wireless signal doing? We'll talk about some of that in this episode, and we'll also talk about how we can troubleshoot every step along the way and help determine where our problems are really occurring. There's no reason to call our internet service provider if all we're doing is popping some popcorn. Let's start with the wireless health of your network. There's some very basic things you should think about when it comes to wireless health. It even becomes more important if there are a lot of houses around you. If you're in an apartment complex, there's going to be a lot of people with a lot of wireless access points around you. So you need to make sure that you're getting the maximum signal strength between you and your wireless access point. Ideally, your access point with the types of devices you would buy on the open market are omnidirectional, which means you put them in one place and they're able to radiate their signal equally in all directions, generally speaking anyway. So you'd want to try to have it in the center of your living facility or the center of the area where you're going to need that wireless connectivity. So already we know that we need to place it in a certain spot. Sometimes you don't have a choice. Your internet connection comes in on one side of the building. You must plug into that internet connection, which may be far away from where you happen to be using the device. You have to think about those things when it comes to signal strength. You also need to pick a channel. With these wireless access points that you would purchase, you can buy it from the store. You can bring it home, plug it in, and it just starts working. You don't have to configure anything. You don't have to put any IP addressing in. In the vast majority of cases, there's nothing you would have to do to be able to get that to operate, but it's not operating optimally. For instance, most wireless access points do nothing with encryption. We have another podcast we did previously that talked about security and how you can secure these things. So you want to be sure it is secure, but you also want to be sure that you're choosing the correct channel for this to operate on. We'll talk more about the channels in just a moment. And here is perhaps the key, is you want to avoid the neighbors. Whenever you start working with wireless technology, it's a lot like listening on an old ham radio or an old AM radio. You're driving down the road and your one channel is fading out, another channel is coming in, and you can really hear two radio stations at the same time. The same thing happens when you're on a wireless network and you don't want to hear your neighbor's network. So if you could change the channel or move away from their communication and use frequencies that nobody else was using, the efficiency of your wireless network is going to be greatly increased. And you want to be sure that you're always checking on that, because the neighbors could be putting up new access points. Somebody on the other side of you could purchase a new access point right now, put it on, and already they might be conflicting with the signals that you're sending out. So let's use some utilities to be able to do something like that. Let's talk about these channels for a moment. Before we get into the troubleshooting part of this, we need to have a better understanding of what channels are available to us and which ones would be optimal to use. This is a great diagram that shows these are 802.11b and G wireless channels. 802.11n, which is a new 802.11, might use these channels. It might use some others as well, but I think this would give you a pretty good idea of what you can look at least initially. In the United States, we use channels 1 through 11. In other parts of the world, you have other choices like channels 12, 13, and 14. Those are not available to people inside the US and in some other countries as well. What's important to think about and look at when you see these channels is you can see that they overlap each other a bit. For instance, channel 1 is this channel. Every single one of these channels is 22 megahertz wide. It goes from 2.400 gigahertz all the way up to 2.422 gigahertz. And you can see channel 2 kind of starts right there at the very beginning of 1. In fact, channel 3 also overlaps, and channel 4 overlaps. Channel 5 goes right snug with the very end of the channel 1. So we're seeing a little bit of overlap here. We're seeing quite a bit of overlap here with these channels, which is why whenever you start setting up an access point, you'll notice the access points from the provider are usually set up to use channel 1, channel 6, and channel 11. And this is why, because channel 1 is out here all on its own. Channel 6 is also out here all on its own, nothing in between, nothing butting up against it. And channel 11 is all out here on its own. So already you can see if you're going to use a wireless channel, you know that if you choose 1 or 6 or 11, it's not going to conflict with one of the others. So if I use channel 1, channel 6 and 11 can't possibly conflict with me. If I choose channel 11, 6 and 1 can't possibly conflict with me. So already we're kind of separating things out. It is very rare that you would need to use any of the channels in between. It's interesting that those are available just in case there happens to be something in your environment with a very narrow bandwidth that might be using other frequencies there. But generally speaking, we don't see anybody ever using those for this very reason. So now let's see how we can see what channels being used by our wireless access point, and let's see what the neighbors are using. I want to be sure that I'm not conflicting with any frequencies that might be around that my machine or my access point might be able to hear. If you do heavy-duty troubleshooting of wireless networks, you may maintain a wireless network at your place of business, then you're probably already familiar with MetaGeek. They have some fantastic tools for wireless. This is one called Wi-Spy. It has this USB connection you plug in and you get these great frequency charts of exactly what's out in your environment. Very, very, very detailed. For the purposes of what we're doing at home, we don't really need to be quite so detailed. What I really want to know is, what are my neighbors doing? And am I set up in a way to optimize my communication? If you go to the download link here, there is a free tool down here called Insider. If I click on that, there's the Insider download. Absolutely free. Download that and install it, and it will run in your Windows XP. It will run with Windows Vista, with Windows 7. It runs very, very well. So feel free to install that. We're going to run that right now and see what my neighbors are doing and what my access point is set up to, and we'll see if I'm optimized. Insider is great. It works on 2.4 gigahertz networks. It works on the newer 5 gigahertz networks. You've got a lot of different capabilities here. What you want to do is choose your wireless card. I have a lot of different cards in my computer. You can see there's a lot going on in my machine. Find the wireless card, and fortunately, it usually has the word wireless as the name of the card, and then click Start Scanning, and then just sit back. What we want to do is see what pops up here. And what we're really doing is your wireless card is simply listening to what's around you. And you'll notice as you sit here and wait, more and more things will pop into this list. You can be anywhere with your technology, with your devices, with your computer. You can pop this up and really see exactly what's happening around you. Now, in my network, I'm this odd name, WATPOPWUA. That is the name of my wireless access points. And one thing you'll notice is that they are much higher than any other devices out there. You also notice that we have a channel 1. There's this Linksys wireless access point that's on channel 6. And then on channel 11 here, we have my wireless access point and another one. Whoops, it's like another one popped up over here called Happy. I'm finding all kinds of things wandering around the air here in my neighborhood. So if I look at this, I can start to see exactly what's going on. Now, by the way, the reason that I'm seeing a wireless access point with my name on channel 1 and channel 11 is because I have 2 wireless access points. I have one that's on one side of the house, and I have one that's on the other side of the house. Happens to go through the kitchen all the way. I mentioned earlier about you may have be only able to plug into one side of the house and not put it in the center. That was my situation. So I ended up running a single cable, an Ethernet connection all the way into the bedroom and putting a wireless access point somewhere up high where we can't even see it. And I plugged it in there. So I'm covering the entire house with really 2 access points. But now what I want to be sure of is, did I really choose the right channels for this? Well, if we look, I'm choosing channel 1 and channel 11. And I can see here the signal strengths, the relative strengths of these different access points. Now, right here in my office is this one that's running on channel 11. And I might want to look at this and think that it might be better off if I take that wireless access point that's running channel 11, maybe better to run it to channel 6, because this Netgear is already running at channel 11, and it's apparently a little bit closer to me than this Linksys device because its signal strength is a little bit more than mine. So I might want to change this around. I might want to change this from a channel 11 and change it to channel 6. So already I'm starting to see some opportunities where I might be able to improve the performance of my network just based on making a few changes with the frequencies that I see coming through on my network. One of the challenges you always have when working with a network is sometimes it's on and sometimes it's off, but occasionally our problem will be that the performance is bad. It's very slow. And you want to know, is the problem that it's slow based on problems with my wireless connection? Is it based on something with my internet connection? Is there some other way that I can work to optimize what's going on? So let's look at some do-it-yourself troubleshooting on your home network. The first thing we'll look at is connectivity. Can I really get out to the internet? If you're not able to communicate on the network, there's some things you can do to help determine where along the line am I really not connected to the internet any longer. We may be able to work just fine within our house, but outside of our home might be the problem. I'll show you how to confirm that. And secondly, we may be worried about the performance, about the speed of this. Once we get connected, perhaps we're not going as fast as we thought we might want to be. So we may want to look at the speed connection and do some tests, run some performance tests, run some speed tests through here to find out how fast really is our internet connection. When we start looking at troubleshooting connectivity, we're going to need to know the layout of our network and more specifically the IP addressing that's on our network. This is going to get a little bit geeky, but it's relatively straightforward, and I'll take you from the very beginning to the very end so you can follow through with this. If you've never seen these IP addresses before, that may be something new to you. This is how we number every device on the internet. Every device has a different number, unless you're, of course, behind a router like this. You have a 192.168.0.1. That's the IP address of my home router. That's the IP address it had when I brought it home, and I just left it that way. I'll show you how to confirm that. Here's some IP addresses of other devices inside of my network. Notice that on my home router, there's an address on the inside of my network. There's also an address on the outside of my network. That router sitting right in the middle. It's the thing protecting me. It's also a firewall that takes and it terminates that connection from the internet, and that internet connection 69.243.229.64. Now, these numbers are something you don't have to memorize. You can easily look these up and see where they're coming from, and I'll show you exactly how to do that and how we can also communicate out to Google and find out how we can see if we're able to communicate all the way out to the other side of the internet and back. In Windows 7, a way that you can start getting some of these IP addresses is from the control panel. Well, let's do that right now. We'll go to our control panel, and in here is an option for the Network and Sharing Center. When that comes up, we have an option here to change adapter settings. We're not actually going to change anything, but what that does is bring up a list of every adapter that's in our computer. Now, hopefully your computer won't be quite as convoluted as mine is. I've got a lot of things going on here, but here's our wireless network connection that we were looking at earlier, and I'm going to right mouse click on that and choose an option that says status. The status view brings me up a list of showing me that it's connected to the internet, it's enabled. Here's the SSID on my wireless access point. What I'd like to see now is this details option. And here's where you're getting into a lot of the interesting IP information. The IP address on this particular adapter is 192.168.0.9. And to figure out where our router is, we can look to see the default gateway. That's another name for the default router that we use to get out to the internet. And its address is 192.168.0.1. So already I know where I am. I'm at 192.168.0.9. And I know the next step when I send any information to the internet that it goes to 192.168.0.1. From there, we may want to know what is our connection, what is the IP address on the other side of this. So one of the things that we can do is bring up a browser screen and connect to our router. We know the IP address of our router, so let's go to our browser and just type in the IP address of our router, 192.168.0.1, and hit enter. And your router is more than likely going to give you a message that says, you need to log in with a username and password. If you've never set one on the router, then you're going to need to look at the documentation for your manufacturer's router, and it will tell you what the default login is. Now on mine, admin is the default username, and then I've changed the password to be something specific to me so that nobody else could walk into my house and use this device, get on my network, and be able to access the administrative capabilities of my router. When I click login, it's going to take me to a screen that says this is a Netgear wireless access point router, and it has WGR614. That's the model number. Here's where we start to get some really interesting information about internet connectivity, domain name services, which we don't have to necessarily know too much about at the moment. We can also get information about the status of the router and how the basic and wireless settings are set up in here. Let's stop for a moment and look at how it's configured currently. It gets my IP address dynamically from my internet service provider, and it has already assigned one that says the IP address that's coming directly into my router from the internet service provider is 69.243.229.64. So already we're starting to build out these things. If we go back to the picture we looked at earlier, let me bring that up. This picture does show me 0.8 is my wired connection. The wireless was 0.9. It goes to 192.168.0.1 is my home router. And we just found out that 69.243.229.64 is the connection to the internet. At this point, we have all of the information we need to start determining how our connectivity is all the way from our workstation to my home router, to the outside of my router, and ultimately perhaps all the way out to Google's public DNS server, which is a great server to test with, primarily because its IP address is so easy to remember, 8.8.8.8. What I'd like to do now is bring up a command prompt, and we're going to start testing the connection all the way from where we're sitting all the way out to Google and see how our connectivity is. So let's go to our Windows menu, type CMD and hit enter, and it's going to bring us up into this command prompt window. What you're able to do now is start using the ping command here at the command line to determine how far you can get. For instance, if I type in ping and I type in the IP address of my home router, which is 192.168.0.1, and I hit enter, you can see that we're getting a reply back from our router. So I know wirelessly speaking, from my machine to my router, I'm communicating fine. Now we'd like to see if our internet connection on the other side is responding properly. We'll use the ping command 190. We're not going to ping 192. We'll ping 69.243.229.64. So I've already pinged this side of the router. Now I'm pinging this side of the router, and we're going to hit enter. And that's responding to me as well. So I know that I can at least get to the outside of this and the internet service provider's connection on the outside of this. Now, if you'd really like to see on the far outside, there's actually a gateway or a router that's on the internet side of things at the internet service provider's facility. And this can really help you determine if we really are getting out to where we should go. To get that information, we can look back at the information we had from our internet IP address settings in our router, and it says that the default router is 69.243.228.1. I don't know where that router is. It's at an internet service provider's facility somewhere, but at that point, it's outside my house, and that's a great way to tell if your connection, at least locally in town, is working properly. So 69.243.228.1, let's do that one. I'll ping 69.243.228.1. So I know that because I'm getting a response, I'm going all the way outside of my house, down the street, and to another building somewhere that's probably at least a little bit local to me in a geographical area. But the important thing is here, I know it's not my wireless connection. If I'm having a problem, it's certainly not with my router. It's not with the basic function of connectivity between me and what's happening, at least on a local level. And ultimately, if you'd like to see if Yahoo is there or if Google is there, we can do 8.8.8.8. And this is the Google public DNS. So that's a server that generally should always be available. And I can go all the way out to that. So I know I could have sat down and first thing typed ping 8.8.8.8, and it would have been able probably to come back with a response. And that means I don't have to go through all of the little pieces that we did up to that point. But hopefully you're able to see how you're able to take it a little bit at a time just to see exactly where the problem might be occurring. Knowing that we have connectivity is one thing, but what if the performance is just horribly bad? What if it's very slow when we're going to one of our favorite websites? We may want to run a generic test out to the internet somewhere that's able to determine how fast is our connection. One of my favorite sites for this is speedtest.net. It's very easy to remember as well. It brings up a picture of where you happen to be. It's already determined that I'm somewhere here in the Tallahassee area. And one of the things I can do is run a test right now, either to there or anywhere else I might want to go to. So you can run multiple tests to different parts of the country. What we might want to do, for instance, let's run a test all the way out here to the Salt Lake City area. And now we'll put that connection there. When we click that star, it's going to start testing things here. It's testing latency. It's preparing a download. It's now downloading the connection and showing me how fast in megabits per second can I download from that facility. Then it puts information back, uploading it to that facility, and we'll see how fast I can go there. And if I look at the comparison of this, I have this that shows me I'm getting 7.4 megabits per second down. I'm getting 3.29 megabits per second on an upload. These are pretty good numbers for my connection, and it does show me that my ISP is Comcast cable, which is true. And I was going to this server that's in Utah that's about 1,700 miles away. Now, what you want to do is make a note of these things. You can copy a link here. You can put this into in the forums so that you can share with others what you're seeing. But the important thing is that you run this when things are good. That way you can come back to speedtest.net, run the test again. And if this comes up with 2 megabits down and 0.2 megabits up, you'll know that there were some drastic changes, some very big problems. You can communicate to the internet, but the performance is very bad. So now you can start talking to your internet service provider and ask them what changed between the time it was running at high speeds and the time that it's running now. I need to find out more about where the problems might be occurring with performance. One of the things that's nice about the internet and our technology today is a number of things that we did not have access to previously are now available in our home. We can do video editing that you see with this podcast right now. I've got amazing graphics functionality on my very large monitor, something we didn't used to have. And you have access to run some very, very technically detailed network troubleshooting tools that 15 years ago used to cost tens of thousands of dollars. Now you can run them for absolutely free on your desktop at home. Now, that doesn't mean that you'll know exactly what you might be looking at. It does take quite a bit of training to understand the nuances of packet communication over the network, but it is something that's immediately available to you and absolutely free to run. Let's run Wireshark on our desktop. I'll show you how this works. Wireshark is a great utility, allows you to see exactly what's going over the wire, every packet. You get down to the very, very detailed level where you can see every communication going out of your computer and every communication going into your computer. If you've ever been somebody who wanted to know, when you plug in that cable or that wire, how's that working? What's going on under the surface? Where are all these IP addresses going and how do they get from point to point? Wireshark is a great learning tool to help you understand more about that. On the Wireshark.org website, you can go right to the download Wireshark link and you can download the latest Wireshark that's out there. And there's a Windows installer. You can also see there's an installer that you can run on a portable apps USB drive. We've done that on earlier podcasts. You can see there's some for OS X. And if you want the source code itself, you can grab the source code. This is open source. You can even help contribute to this and even make Wireshark better. When you start Wireshark for the first time, you'll have a number of options to capture from any of the interfaces on your computer. You can go to some capture help here. There's a number of files that I've previously captured on mine. We won't be accessing those. Sample captures are out on the web. You can see what other people have captured to help give you an understanding of what you're looking at. And you can, of course, go to the website, the user's guide, or look at how security is related to using Wireshark. What we're going to do is I'm just going to choose one of the interfaces out here on my system. I'm going to choose this gigabit Ethernet connection that's plugged in on my computer, and we'll see what packets go back and forth. You'll see things that are going out over the internet and the types of connections I have. You can see the different types of protocols. It's color-coded to give you a feel for the different communication. What you see on the screen here is the number of the frame that's been captured, the amount of time that goes between the frames. It's a delta here from the very beginning. You've got the source address. In this case, it's either an IP address or in some cases even a MAC layer address that's communicating out, and the destination of where that's going. Some of these things are going from my network internally out. Other parts of these packets are coming from the outside and coming in. You'll notice that there's a lot that goes by on the screen. This is a relatively advanced troubleshooting tool because there are literally thousands of protocols that you could pour through with all kinds of different communication. Every single protocol is a different language unto itself. You almost have to understand the way that all of these different languages are communicating. Imagine if you had to know English, French, German, Russian, and many, many other languages all at once. That's one way to approach this idea of network troubleshooting. I'm going to have it capture a few packets here, and then I'm going to stop it because this really goes by very fast. There's at the toolbar a button here to stop the running live capture. And you can see in this very short period of time when I've really been doing nothing, all behind the scenes, there's been network activity. And always on your network, you'll notice there's always network activity. And you can see this here is this network activity. You got 113 frames and all kinds of different protocols. When you click the different frames, you'll see that these packets here are also displayed down here on this screen. This first top window is a packet by packet breakdown in a summary mode. You've got this more detailed view that's in the middle of the screen, and you can adjust these to make them larger or smaller. Here's the more detailed view, and you've got plus signs that allow you to expand this out so you can see more of the protocol decodes of really what went back and forth. And down here on the bottom of the screen is a hexadecimal representation of exactly what was in the packet. This is really quite a bit of detail. And if you ever are in a position where you're trying to prove to somebody what is happening across the internet, and they're saying it would really help a lot if I had a packet capture of what was going on, then you do exactly what we just did. You turn it on, you let it run. When you're finished, you stop the packet capture, and then just like any other Windows application, I have a file save where I can save this packet to my hard drive, and then after that point, I'm able to now send it off and have them examine what was in those packets. So even if you don't necessarily understand all of the details here, it is an incredibly valuable, wealthy bit of information that we can provide to someone else. One thing to keep in mind, these packet captures may also contain private information. If you're not encrypting communication, it might have passwords in there. Usernames might be in there. You should not give packet captures to anyone unless you trust what's in there, or you've already gone through the packet capture and gotten rid of things that might be private. So keep that in mind, that this is a very detailed troubleshooting tool, but it's also a very big security risk. So you want to be sure that if you share this with anyone, you know exactly what you're giving them. Now you've seen how to look at your wireless network, make sure it's running on its optimal channel and you're not conflicting with what your neighbors are doing. We've gone through some basic troubleshooting steps. We can now determine exactly where problems might be occurring from our side of the internet all the way to the other side. And if you want to get into the ones and zeros and literally the bits and bytes about what's going over your network, pull up Wireshark and you'll be able to see everything that's going on. If you'd like to be notified whenever we come out with one of our new podcasts, you can visit our website at themobileclassroom.com. You can like our Facebook page from there or get on our Twitter feed at twitter.com/mobileclassroom. If you'd like to send me a message, you can always communicate with me directly at james@themobileclassroom.com. Thanks for joining us next week. We'll see you next time on The Mobile Classroom.